Okay, this lesson is on finding the molar mass of compounds. So we've learned about what a mole is, and we've learned about what molar mass is, and how molar mass is just how heavy or the weight or the mass of a mole of particles. And again, we don't know how many particles are in a mole. We just all agree as chemists that a mole has an equal number of particles in it as anything else. So what I mean by that is a mole of calcium is going to have the same number of particles as a mole of water, which is also going to have the same number of particles as a mole of oxygen. So whether I'm referring to calcium, which has 4 atoms, let's just say is in a mole, or water, which maybe has 4 molecules in a mole, or oxygen, which also is made of molecules, could have 4 molecules in a mole. And again, we don't know that it's 4. It could be 5, it could be 6, it could be 7, it could be 50 or 100 or a million or a gazillion particles in a mole. But my point is that when I'm talking about a mole of an element like calcium, the particles are going to be atoms of calcium. And if I'm referring to a compound like water, because it's a composition of 2 different elements compounded together, I'm going to be referring to molecules. And then when I'm referring to diatomic elements, the particles in diatomic elements are also molecules. But regardless, a mole is going to have an equal number of particles in each. But my mass of that mole of particles is going to depend on the particles themselves and the atoms in those particles. So here's what I mean by that. We've learned how to find the molar mass of an element like calcium. We just look at calcium on the periodic table and we find its atomic weight. And I think calcium's like 40.08. Now I'm doubting myself. Let me double check on my periodic table. Wrong way. Let's see. Calcium, yeah, 40.078. So I rounded a little bit, but that's okay. So since calcium is made of atoms, that means the molar mass of calcium is the same thing as its atomic weight. 40.08 grams per mole. But we also learned that diatomic elements are a little tricky, like oxygen. Oxygen's particles aren't single atoms, they're 2 atoms. So even though oxygen's atomic weight is 15.999, the molar mass of oxygen is going to be double that because each particle of oxygen is made of 2 atoms. So it's twice the atomic weight, which is how we end up getting, sorry that wigged out here. For oxygen, we end up getting a molar mass of 31.998 grams per mole. So the question is, what would we do to find the molar mass of a compound like water? Because water is not made of atoms, it's made of molecules. However, it's made of different elements compounded together. So you might be having a guess of what you might do to find the molar mass. If you've got that guess, I want you to keep in the back of your mind because I'm going to tell you how we'll find the molar mass of a compound in just a moment. Maybe you'll be right. So what we're going to do is we're going to break it down into 2 steps. So when we're finding the molar mass of a compound, we're going to do something called finding the formula weight. It's kind of synonymous when we're talking about finding the molar mass of compounds. So step 1 for finding the molar mass of a compound is finding the mass of each element in the compound. After we found the mass of each element in the compound, we're just going to count the number of atoms in the formula. And that's going to tell us if we need to double an atomic weight or triple an atomic weight, or maybe there's just one of that kind of atom. So maybe we don't have to do anything at all. And then we'll just add up all of our atomic weights together. So let's do an example together. Let's say I was trying to find the molar mass of glucose. Glucose is a pretty big molecule. Its formula is right here. It's C6H12O6. And what that means is that there are 6 carbons. I'm going to try drawing this. Let's do it in some colors here. That means there are 6 carbons connected together. So maybe I should do this in a bigger marker. Yeah, let's do this in a bigger marker. So there are 6 carbons. So 1, 2, 3, 4, 5, 6 carbons connected to 12 oxygens. Oh no, 12 hydrogens. 12 hydrogens. So let me draw that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then there's also 6 oxygens. So let's get a third color. 6 oxygens. So 1, 2, 3, 4, 5, 6 oxygens. Now, I don't know if they're connected to make this shape because that's a lot of atoms. Maybe the shape looks kind of different, but I will have particles that are made of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So if I had a mole of these and I wanted to find the mass of a mole of these particles, I would have to add up the atomic weights of all 6 carbon atoms, all 6 hydrogens, or all 12 hydrogens, and all 6 oxygens. So when I look on the periodic table at carbon's atomic weight, it's 12.011. And when I look at hydrogen's atomic weight on the periodic table, it's 1.008. And when I look at oxygen's atomic weight, it's 15.999. Now, since there are 6 carbon atoms and 12 hydrogen atoms and 6 oxygen atoms, I'm going to multiply the weights of these elements by the number of atoms there are in the formula. And I'm just going to highlight where I got these numbers from. So the C6 told me there were 6 carbons, and then let's do it in yellow. The H12 told me that there were 12 hydrogens, and then let's do red, O6 told me that there were 6 oxygens. So when I multiply these in the calculator, let's see what I'm going to get. I think I'm going to be able to do this in my head. I'm going to get 660 point, that'll be 12, 7, okay, so 82.066, and then, okay, I can't do that one. I can't do the next two in my head. So let's do 1.008 times 12. That'll get us 12.096. 96. And then let's do 15.999. 15.999 times 6. That'll get us 95.994. And then to get the total molar mass of glucose, I'm just going to add all of these together. So 82.066 plus 12.096 plus 95.994. Okay, I think I can remember that. So, nuggets. I forgot everything. 12.096, is that what it was? Yep, okay. Oh, shoot. Plus 994. Ooh, wait, I needed a decimal, not a comma. 0.994 plus, and then the last one, 82.066. Okay, so when I do that, I get, my nuggets. Hold on, can I undo that? Oh, look at that, it saved my work right here. How cool. 190.156 grams per mole. Okay, I'm going to try and fit that in the bottom right here. And I forgot what it was already. I swear, I have short-term memory loss. I'm like Dory. 190.154 grams per mole. If you can hear that in the background, I promise it's not a monster. It's just my dog. He's having a really fun time playing with his bed and just like tearing it up and carrying it around the house. I don't know why. He's got that puppy face still. He likes doing it. I don't know. But anyway, this would be the mass of a mole of glucose, or glucose molecules, I should say, since this is a combination of atoms bounded together. So let's do one more example together of finding the molar mass of a compound, and then I'll let you try a couple. So what's the molar mass of sodium sulfate? Now, I wouldn't expect you to know what the formula for sodium sulfate is. That'll always be provided for you. We haven't learned how to name compounds yet, but we will soon, my sweet butterflies, we will soon. But anyway, let's get started. So according to my formula, there are 2 sodium atoms. So I know that the molar mass of sodium is 22.990. So this is going to get doubled since there are 2 sodium atoms in this molecule. I know that my sulfur has only 1 atom, so my molar mass of sulfur is 32.06. And I can just multiply that by 1 since there's only 1 atom of sulfur in this molecule. And then my last one is oxygen. There are 4 oxygens, so I'm going to take oxygen's mass and quadruple it, multiply it by 4. Milo, geez, Louise, he's having a great time. Just shaking the bit around, holy cannoli. Okay, so now that I've got this all set up, I just need to multiply these across. So I know sulfur in my head, 32.06 times 1 is just 32.06. I think I can do the first one in my head. I'm going to get 0, 8, and then that would be 9, and then that would be 5, and then that would be 4. Yeah, I think that's right. Yep. 45.980. Yeah, that makes sense. Last one, though, I cannot do in my head. So 15.999 times 4 gets me 63.996. I think I could probably do that in my head next time. 63.996. Perfect. So I'm just going to add these 3 weights together, and that's going to get me the molar mass of sodium sulfate. So 45, let's hit plus. 45.998 plus 32.06. And that gets us 142.054 grams per mole. So that is the molar mass of this compound. Awesome. Okay, so this next one's an example that's been set up for you. If you want, what I mean by set up is that it's got this nice table here that you can plug into. If you want to try it without me, go ahead and try it. You can pause the video and unpause when you're ready to check your answer. But if you need assistance going through one more, then just follow along with me. So what is the molar mass of sodium bicarbonate? If you didn't know, sodium bicarbonate is just baking soda. Baking soda is a chemical. If you did not know, it is just a straight chemical that could be used in a reaction. So its chemical name is sodium bicarbonate. But since it's such a common household item, it's got the common name baking soda. But the formula for baking soda is right below. It's Na, which is sodium, H for hydrogen, C for carbon, and O3 for 3 oxygens. So I've got 4 elements here. So I know that sodium's mass is 22.990. Hydrogen's mass is 1.008. Carbon is 12.011, and oxygen is 15.999. Now, according to my formula, there is 1 sodium atom, there is 1 hydrogen atom, 1 carbon atom, and 3 oxygen atoms. So when I multiply across, I'll get 22.990, 1.008, 0.11. And I think I'm going to try this. 15.999 is pretty much like 16. And I know 16 times 3 is 48. But this isn't 16. It's short by 0.001, just that much shorter than 16. So if I had 3 of those, I'd have 0.003. So if I just minus 0.003 from this, that'll get me my answer. So I think I would get 47.997, but let me double check. 15.999, oops, typed that in wrong. 15.999 times 3. Yeah, okay, cool. So I figured out how to do it in my head, so maybe I won't need to use the calculator as much. So 47.997. Awesome. Okay, so I'm just going to add. Let's see if I can really challenge myself and add this in my head. So 0 plus 8 plus 1 is 9, plus 7 is 16. Yeah, so 6, carry the 1. 1 plus 9 is 10, plus 0 is 0, or 10 plus 1 is 11, plus 9 is 20. So that's going to be a 0 here, carry a 2. 2 plus 9 is 11, plus 0 is 11, plus 9 is 20 again, so 0, carry another 2. 2 plus 2 is 4, plus 1 is 5, plus 2 is 7, plus another 7 is 14. 1 plus 2 is 3, plus 1 is 4, plus 4 is 8. So 84.006. I don't quite trust myself. I'm going to plug that in my calculator. So 22.990 plus 1.008 plus 32.06 plus, what was the last one? Oh yeah, I know I didn't do that right. Oh, because it wasn't 32.06, it's 12. Did I do? Oh yeah, it was 12.0. Plus 12.011 plus 47.997. Enter. 84.006. Nice, I got it right. Okay, so 84.006 grams per mole. So that would be your molar mass of baking soda or sodium bicarbonate. So the last one's a try, and the table hasn't been set up for you because in all actuality, you really don't need it. If you want to redo the table, you are more than welcome to. It's a great way to organize your work. But if you don't need the table and you would rather just show your work without it, by all means, go ahead. So go ahead and pause the video, and when you're ready to unpause, you can check your answer with mine. All right, I'm assuming if you're listening to this, that means you're ready to check your answer. So in water, there are 2 hydrogens and 1 oxygen. So I'm going to take the mass of hydrogen, 1.008, and multiply it by 2 to get 2.016. And my mass of oxygen, I'm just going to multiply by 1 to get the same good old mass of 15.999. I'm going to add these two together, and what do I get when I add them together? 6 plus 9 is 15. That'll be 11. That'll be 10. That will be 8. Boom! 18.015 grams per mole is the molar mass of water. Ta-da! So hopefully you were able to get that try. Whether you needed the table or not, doesn't matter. As you continue getting practice with this, you might find that you don't need the table, or you might find that maybe the table is like really valuable for you, and that's okay. So go ahead and move on to the aligned practice so that you are super strong with finding the molar mass of any compound you're given.